Okay, now to TCP traffic. TCP stands for Transmission Control Protocol, and it handles the delivery of packets, including sequencing and errors. So for this demonstration, I will be using the nmap from my Kali virtual machine to scan TCP port 80, so we can have some more TCP packets to display on Wireshark. So I go back to my machine. Let me just clear this. For that, I use the syntax nmap. I specify the port I want to scan, which is port 80, and I specify the IP address of my Windows virtual machine. Okay, so I go back to my virtual machine, and now I can just narrow down my search. So I can just impute the protocol here. Okay, so this was our ML scan. And something about TCP is that TCP can give useful insights, but it's also hard. It can also be hard to analyze due to the number of packets it sends. So, but for this, we got little packets, so that's good. And when analyzing TCP packets, Wireshark can be very helpful and color code the packets in order of danger level. So yeah, this green means good. But what I want to talk about is like a common thing when analyzing TCP packets is known as the TCP handshake, and it includes a series of packets, the scene arc, and the arc that allows devices to establish a connection. So as you can see here, this is from the source, which is my Kali virtual machine. And you can see we just have the same packets. And typically, when this handshake is out of order, or when it includes other packets like an RST packets, as you can see, this red, something suspicious or wrong is happening in the network. And since we did an ML scan in this section, it's a perfect example of this. But the main thing we need to know about when we're looking analyzing TCP is we want to look at the sequence number and the acknowledgement number. And for that, we can go here. So yeah, this is the sequence number, but there's no acknowledgement number here. It's zero because the due to an MAP scan we weren't able to get the three-way handshake, so that's why it's zero. Yeah, because the port was not open. If we go back to my yeah, we can see the TCP port was closed, so that's why we weren't able to complete the three-way handshake, and that's why our acknowledgement number is zero, as we can see here. So that's basically it for TCP. We just need to look at the three-way handshake to see if it was complete, and also the sequence number, the acknowledgement number. So yeah, and the next type of traffic we're looking at now is the DNS traffic. Okay, now let me talk about the DNS traffic. So what does DNS stand for? DNS stands for domain name service, and it resolves domain names with IP addresses. And I will just open a packet capture file I have here so we can see what the DNS traffic looks like. Okay. And there are some things we need to keep in our mind when analyzing DNS packets. And yeah, so one is the query and the response. The second is the DNS servers only, and the third is the UDP, because UDP stands for user datagram protocol, and it's what the protocol that DNS uses to communicate on port 53. So let me go back to Wireshark so I can go a little bit deeper into what I mean. So Yeah, we can just looking at the packets, we can see what is being queried, and we can also see the responses. But I'm going to keep in mind that if anyone if any one of these three things are out of place, then the packet should be looked at further and should be considered suspicious. So let me go back to Wireshark. First of all, let me talk about the DNS query. So let's just look at the standard query packet. Okay. So looking at this, we already have like two bits of information that we can use to analyze the packet. And the first bit of information is that we should look at where the query is originating from. And in this case, as we can see, it's user datagram protocol port 53. Okay, that means it has passed the first check, which is this communicating using UDP on port 53. And if it was TCP 53, then it should be considered suspicious traffic and needs be to be analyzed further. So we can also look at what is querying as well, as this can be useful with other information to build a story of what happened. So for that, we'll open the query. So this is what is being queried here, as you can see. This is the query, and if we want to analyze DNS packet, we need to understand our environment and whether or not the traffic will be considered normal within our environment. So let me talk about the DNS response now. Let me just open a response packet. Okay. So it's similar to the query, just that in a DNS response we have an answer this time around, and the answer is used to verify the query. So this is the answer option here. So as you can see, it means it was a Google server that was queried, and this is the response from the Google server to verify the query. So this is basically how to analyze DNS traffic. But I can just let me go give an insight of what is being queried on this our packet. So if I should go back to packet one, we can see this is what is being queried. This 8.8.8.8 in address. Yeah, but this was being queried in packet one. And if I should just check another packet now, maybe packet 26, I can look for the site that's being queried here. As you can see, it's wireshark.org that's being queried in packet 26. So this is how we analyze the DNS traffic. Another thing we need to take note of is the color coding. So it's blue. UDP in Wireshark, UDP packets usually have this color, which is blue. So in DHCP traffic, we also have this color coding. So that's it for DNS. So thank you for watching.